Okay, this is the second part to lesson 1.7. We're going to use some different formulas just to keep practicing being able to isolate variables in the formulas and solving for different information. So example 2a, the formula C equals 65t divided by r minus 65 computes the number of C hours needed for one car driving r miles per hour, so the r is the rate, to catch up to another car that is t hours ahead and driving at 65 miles per hour. Solve the formula for t in terms of C and r. So we are going to solve this formula with t on one side and everything else on the other side. So let's work on that. C equals 65t divided by r minus 65. Okay, we want to get rid of that r minus 65 first. So we're going to multiply both sides by r minus 65. Those r minus 65s cancel out on the one side, and we're left with c r minus 65 equals 65t. Now we want to divide both sides by 65. Those cancel out, and we're left with t equals c r minus 65 divided by 65. Finally, we want to distribute that c to both parts. We have c times r minus 65c divided by 65 equals t. So we just solved the formula for t in terms of c and r. In example 2b, because the density of air consumed by scuba divers increases as they dive deeper, they consume more air the deeper they dive. So here's the next formula. It's t equals 30s divided by d plus 30. It's used by some scuba divers to estimate the number of minutes t of air they will have, so minutes is t, at a depth d in the seawater, if they consume a tank of air at the surface in s minutes. So we're going to solve the formula for d. D is going to be on one side of the equal sign. So t equals 30s over d plus 30. We're going to multiply both sides by d plus 30 just to get rid of that bottom part. They'll cancel out, and we're left with t times d plus 30 equals 30s. Now we're going to divide t from both sides because we still want this in terms of d, so not s but d. So we're going to divide both sides by t, cancel out, and we have d plus 30 equals 30s divided by t. Now we're going to subtract 30 from both sides. Those will go away, and we're left with d equals 30s over t minus 30. So now we solve the formula for d in terms of t and s. Okay, next we're going to use the volume equals pi r squared times h for r. We're going to solve for r in that same formula we've used. So we want to solve for r. We want r on one side of the equal sign and everything else on the other. So v equals pi r squared h. We're going to divide both sides by pi and h. The pi's will cancel out, the h's cancel out, and we're left with r squared equals v divided by pi times h. Now we want to get rid of that squared, so we got to take the square root of both sides, because we know if we have the square root of 3 squared, it equals 3. So if we take the square root of r squared, it'll be r, and that's what we want is r. So, but we got to do the same thing to both sides. So we got to take the square root of both sides. Okay, we know the square root of r squared, like I said, means it's r, that equals r. And we have the square root of v over the square root of pi times h. And that h is inside the square root as well. That is solving for it in terms of r. Okay, part B, assume a fixed volume of 500,000 cubic centimeters. Write the formula for r in terms of h only. So now we're going to use that formula we just did but we're going to add that 500,000 in there because we're still solving for R, and we already did that, but we have a volume now. So we can say R equals the square root of that volume, which is 500,000, divided by the square root of pi times h. And that's what we can do for that problem. That's what it is. So we wrote the formula for R in terms of h only, and we plugged in 500,000 for the volume. In example 3b, a certain ancient pyramid has a volume of x cubic centimeters. Each side of its base is 231 meters. Solve v equals 1/3 b times h for h. So we're going to solve for h. So volume equals 1/3 area of the base times height. So we want to get h on one side of the equal sign and everything else on the other. So we're going to divide both sides by 1/3 b. The 1/3 and the b cancel out, and we're left with h equals volume over 1/3 b. If we have a fraction on the bottom, we know we can flip it, so we would have h equals 3v over b. That is solving for that in terms of h. Now in part B, we assume that the pyramid has a volume of 2,614,689 cubic meters. What is the height? That's that h. They want to know the height. And we already got the formula that we're going to use for this. So let's substitute in. So height equals 3 times the volume divided by, now we need the b. b is the area of the base. Well, for a pyramid, this base, it said each side of it is 231 meters. So the base of this pyramid is actually a square with each side having a length of 231 meters. So we know that area of that square is going to be 231 times 231 because the area of a square is side squared. So we're going to plug, and that equals b, the base. So b for the bottom would be side squared. It would be 231 squared. Make sure you do the squared first and then you do the rest of the division. You should get an answer of 147 meters for the height. H equals 147 meters.